Hi, in this video I want to show you the new improvements in Pandas version 2. Now Pandas version 2 is not it's a stable version. I use the pre-release version of Pandas version 2 to show you the new improvement in Pandas V2. First, I should install Pandas version 2. Now that I'm taking this video, this pre-release version is available. First, I install this pre-release version of Pandas V2. In Pandas V2, we use PyArrow backend in addition to NumPy. Before Pandas V2, Pandas used NumPy as its backend for manipulating data. But now in Pandas V2, PyArrow backend is added. PyArrow backend is faster and more optimized. Okay, now I check if Pandas V2 is installed. Pandas SPE. I check my Pandas version. Okay, now I'm using Pandas V2. Now, the default type in the default behavior of Pandas previous to version 2, I should say that I create a data frame. Default Pandas Now I create a data frame. For example, I want to have a data frame of some students. I want to this data frame contain their age and their name. So and for example, Julie 15. Now I create a data frame with that. Okay, I want to have two columns, for example, name and age. As you can see here, I create a data frame uses the default behavior of Pandas. If you see data frame, this data frame contains two series. First series is name, the other series is age. As you can see here, all name series contains string values. The default behavior of Pandas is that all the string values is contains in object data type and integer values as int 64 data type. That's not an optimal solution because object is not suitable for many object data type is not suitable for working with many string operations, and it uses more time to do string operations. But in Pandas V2 with using PyArrow as its backend, other things changed. First, we see that, for example, here I import NumPy here. NumPy, as I said before, is the backend for Pandas series. And in the created data frame, for example, the name series has this value. If I take the type of this value, you see that it uses NumPy array as its default for containing values of any series in the pandas. And in the age, if I check age series, you should see that it two series name and age, both of them uses NumPy as their default backend. Now I want to use PyArrow. Okay, data frame with PyArrow backend. Now I create data frame with PyArrow backend. Okay. First, I want to show you that this backend, I want to create two series. I show you the type of these series. Okay, for example, PyArrow name series. This series I want to have values of values of my created data frame, all rows and columns, first column 0. And here I say that we want to use PyArrow backend. PyArrow backend. And the value is I want to use, okay, here is my created data frame. I get all the values in the first column 0 here, and I want to save that as a PyArrow string backend now. Okay, and also I want to have another string, another PyArrow series for age. That's second series, and it contains int 64 data. Okay. Now I use PyArrow if I want to create a data frame with these two. Name series and PyArrow series axis 1. Okay, I create a PyArrow data frame. As you can see here, the value is the same as the original data frame, but the type of this value, if I check this, if I get the name info for the series, you can see that all the values are saved in memory as a string data type. And here for age series, all the values are saved in memory as int 64 data type. But what is the difference between object and string for saving data? Okay, one difference is better performance in string manipulation tasks, and another advantage is better missing value management. Better, okay. Better missing value management. Okay. For instance, in my PyArrow data frame, this PyArrow data frame has these values. I want to put here I want to put this as none. For example, in this age, this age I want to be none. Okay, now let's get info. You can see that here nothing changed, and we have non-value. Okay, I'll put this value raw with index 2, column age none. As you can see here, there is non-value here, and it shows that that's non-value. Now check if I do this in ordinary data frame. Or ordinary data frame is this data frame. Okay, and you see that it has int64. Now, if I put a value to none, you can see that it automatically changed the series to float 64. Automatically changed the type of the series. It has previous, it had the type of this series was int64. Now it's float 64. Means more memory usage. Okay. Now another difference. For example, I want to create two series. One series I use PyArrow bool type, and another series is ordinary series in Pandas. Okay. Now if I check okay, as you see here, arrow for Boolean type use less memory than ordinary Pandas arrow for Boolean type. Do you know why? Because in ordinary type of Panda in NumPy, any boolean value get 1 byte, means 8 bits of RAM. But in PyArrow, any boolean get only 1 bit, true or false, 0 or 1, only get 1 bit of memory. As you see here, Arrow get less memory than for PyArrow uses less memory for boolean type than Pandas ordinary NumPy arrow. Okay, but another advantages here is that, for example, one value, I want to put one value none for both of the data frame. Pandas data frame on the backbone of NumPy and PyArrow data frame. Okay, PyArrow series. And now, if you see, here we have 4 values, and it shows the 3 non-null value of type boolean. But if I use ordinary NumPy series in Pandas, having one non-value make that object of type object, and as you see here, it uses more memory than memory that it used before. As you can see here, having one non-value here change the type of the NumPy array from boolean to object and uses more memory. Okay, another advantage is that PyArrow has is for speed of PyArrow. PyArrow is faster than ordinary NumPy array. Okay. Here I saw. Okay. PyArrow data frame. Cool. Okay, let us define series. Okay, NumPy series, I define a NumPy series with the value pd dot series with the value okay, and I define PyArrow series. Okay, the type must be int 64 PyArrow. Okay, I define 2 series, one NumPy series and another one PyArrow series. Okay, let's define a calculation on these 2 series. For example, I want to see that how much time it takes to do some calculation. For example, time it in the series I want to get mean. Okay, now I want to do the same calculation for PyArrow series. Time it. The same calculation for PyArrow series. As you can see here, PyArrow is much more faster than real NumPy arrows, Pandas original NumPy arrow. As you can see here, PyArrow is much faster, can calculate much faster than NumPy. Okay. Another test speed of PyArrow. Okay. Another test is here. I have a, as you can see here, I have a data set. The data set is here. This data set, I have this data set here. This is a data set for automotive data. I downloaded this data set and uploaded here to my Colab. Now I want to load this data set using PyArrow and load this data set by ordinary NumPy version of Pandas, original default version of Pandas. Okay. First, Pandas default. Okay, now I did here read. With CSV, I copy path and here I paste the path. Okay. How much time it used? Now I do the same operation, reading dataset using PyArrow backend of Pandas. Now df here I do PyArrow. Now I says that use PyArrow engine. Use PyArrow engine, and also I should use take this flag to true, no label. The type to true. Okay. Now I read this. I want to read the same dataset using PyArrow back. Okay, as you see, it is much faster than ordinary Pandas default backend. That default backend is NumPy. As you can see, PyArrow is faster for using for data calculation and for reading data. Okay, now I want to check the speed of the calculation on the string data types. Now I create here two speed on this and speed on the string called string operations. Okay, now to see a string operation, first let's say this loaded pandas. Okay, this loaded data frame here, you can see, or for example here, to show a string operation, I want, for example, to get all the all the columns that in this series, in all the values that in this series column make column starts with A. For example, I want to get all the string that starts with A in this column. Now this make column. To do that, first I do this with default data frame. I want to get all the values in make column that starts with, for example, A. And it shows me that how amount of time it takes to get the value. Starts. Okay, you can see how much time it takes. Now I use the same operation on the PyArrow data frame. As you can see, it's faster that PyArrow data frame is faster than NumPy data frame. Another advantages of PyArrow is in interoperability. Before Pandas V2, PyArrow was only Spark and Polars. Now, by using PyArrow as a backend in Pandas, PyArrow data can very efficient transfer between Pandas, Polars, Spark, and also to all language. Like a CSV file, for example, the CSV file can be used in any language. PyArrow is a data type in memory that you can transfer that to Spark, to Polars, to Pandas very efficient way. I see how you can do that. First, I install Polars. Okay. Now, okay, I import Polars as PL, and first I check Polars version here that I have now. Okay, I have Polars in my notebook. Now I want to create a Polars data frame by using PyArrow. I use df. I use define a variable df Polars, and I use pl dot. I get that I want to get data from Pandas. Pandas. Now the data frame name, my data frame was here, df PyArrow. Now, as you can see here, I have this data frame in Polars. I would type easily I transfer data from pandas to the polars. Now I want to group columns by make column and then calculate total price of each group. You can see here how I can do that. You can see here the make column has many values. I want to get total price, sum of the price of each group. For example, AOD, sum of the total price of the AOD value. I want to do that in the code, as you can see. I group data by make and then use aggregate function on the price column, cast the price column due to the fact that this price column is in a string. Price column here is in a string. You can see here is a string. I cast the values of this column to integer and drop null values. For example, you can see here I had null values and drop null values. Then I put sum on the price column, and after that I alias the column to the total price and shows the result. You can see here. As you can see here, total price for this make is this value, and for AOD is this value, and etc. And now also I can now change this value to the Pandas data frame, transfer this value to the Pandas data frame. I get all of the result of this column in this value. All of the result of this query is in this value, and now I use two pandas function to transfer the values to pandas data frame. Pandas, I save that to the pandas data frame and see the result. Very easily, as you here, I read the data by using pandas, PyArrow, then transfer that data to the polars, and in the polars I run a query on that data, this query, and get the result, and then change the result of the query to the pandas, and you can see the result. Now, as you can see, this is efficiency of using PyArrow in the pandas. Another improvement that exists in Pandas V2 is having copy on write mode, this code. Before Pandas V2, if we create, in here is the code for before Pandas 2, if we create a data frame here, a data frame, this line will create a data frame in the memory for us. For example, if this is memory here, it creates a data frame with the name df in memory for us. But this line will create a pointer to this, a pointer with the name subset to the first series of the df data frame. Now, if we change the first item in this series, it means that the first item here will be changed, and it means that here the first item here will be in the df data frame, and also subset data frame will point to that. Means that df data frame, the first item for df data frame is changed here. Here, as you can see here, we changed the first item for subset series, but here the series, here the subset is a pointer to the first item in the df data frame. Means that the first item in the df data frame is changed to the 100. But in Pandas V2 all the things changed. Here, if in Pandas V2 all the things changed, it means that if I set this flag to true, copy and write to true, it means that here if I create a data frame with the name df in the memory, I have a df a location for the data frame and with the name df. And here if I write this code, subset equal to the first series in the df data frame, because of this flag copy and write, it copied it point subset create a pointer to this data frame, but after changing any value in this in the subset, after changing any value in the subset, it means that this pointer will be destroyed, and a copy of the df data frame in the df data frame will be created in the memory, and the first item in this subset will be changed. It means that changing the first item in the subset doesn't change any value in the df data frame. As you can see here, the first value in the data frame is 1, opposite to the first value in the data frame in the Pandas previous 2, that was 100. Okay, that was the most important changes in Pandas V2. Have a nice time. Bye bye.